Test, 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 test. Okay, yeah, this should be good enough.
Hi everyone, welcome to OS Dev Talk COE 2022. Um, so, today in this talk this year we are going to talk about the OS infrastructure developments with laser being adopted more and more over time. These infrastructure changes are becoming more and more important as we go by. For this talk, I will be accompanied by Pepe virtually. Please welcome him on stage.
Can you see me?
Yes, they can see you and we can hear you. Welcome on stage, Pepe. How are you doing?
How's it going?
Oh,
I'm doing great. How are you guys going?
I think they're doing great. Are you guys doing great? I
Yeah,
think we
I'm
got
sorry
it.
I couldn't be there this year.
We couldn't
But
tell what you said because we are talking over each other.
no, I'm sad I couldn't be there this year.
Ah,
I'm hoping to make it next time though.
if COVID comes down, are you going to show up next year?
Yeah, for sure.
All right, that's nice to hear. Thank you very much. Okay, I guess we can start the talk now. Please, Cavo, switch to the slide scene. There we go. Go ahead, Pepe.
Okay, let's try and make this happen. I've got a lot of windows open and I'm going to be trying to forward slides in two different places, so fingers crossed I can get this right. So, yep, this talk is going to be on the OS infrastructure, which is a bit different from the usual talks I give, but hopefully we can you know, make it interesting along the way. It's not gonna, I've tried to make it not too technical so everyone can follow along, maybe learn something along the way. So I am Pepe. If you don't know me already, Programming is my life. It has been since I was about 4. Started programming on a Commodore 64, and from there I kind of like started programming from the user manual that came with the PC and had a lot of sample code in it. And yeah, moved on, got a 486DX4, 100 megahertz. That was a big thing for me. And I've always been programming applications, games all my life. And yeah, I think that skipped a slide. That's going to be weird. Okay. Yes, gaming is life. I've always been following rhythm games since I was young. DDR, Beatmania. In the local arcades, we had a few of those around at certain points. And DJ Max was a big one for me. That was a PC release, a Beatmania style game. It had online support, it had chat. It was one of the first games that kind of, feels like OS, PC-based rhythm game with multiplayer and whatnot. Yeah. And also, obviously, OS Tatakai Oendan, which was a huge reason for us existing, I guess you could say. And yeah, OS has been the last 15 years of my life. I've dedicated everything to this game. Most people already know that. So let's move on. You can see it's changed a lot over the years, especially more in recent times, or less in recent times, depending on who you ask. And we've been doing a lot of work on the release of OS Laser and the framework that we run it on. We've basically made everything from the ground up again, and we're getting close to pushing that out to more and more users. We've already got a pretty big user base using it, but yeah, it's ongoing development.
Can you
And for
remind
anyone that
us?
think,
Oh, sorry.
yeah,
Can you remind us, since how long have you been doing this whole rewrite?
I think it first started in 2017. We tried to like refactor the existing code and it didn't go so well, so we started rewriting from scratch. And that's taken a good 5 years, or 8 years, or maybe 15 years, depending on who you ask. People make up numbers. And for anyone who says that like OS hasn't been getting many updates lately, you should really test out Laser because we've been pushing like every week huge numbers of new features and just getting things in a state where it's ready to push out to the rest of the user base, because that is the end goal. But today we're not talking about Laser, which is a bit different from usual. Before we go any further, let's get Poon to introduce himself.
All right. So, hi everyone. I'm Poon. That's one of my best Twitch emotes. How much of the audience actually knows me in some way or another? Can you guys raise your hands? Okay. So I think most of you know me as a player back then because I signed up to us in 2011. I was 11 years old back then, and I took the game a bit seriously in between 2014 and around 2020. So I went competitive on it, and I I started picking up tablets on February 2015. I actually got one of the first 500 OS tablets ever produced. They were by Weon back then, and they sold out for like $30 USD. Yeah. Since then, I've built a career. One of my proudest achievements is managing to be the national champion 5 times in a row in France. But you guys know me better for my chalk compilations, I guess. Yeah. So you guys might be wondering what have been my whereabouts since then. Well, I've done new endeavors that I've somewhat started late in my career and kept doing since I quit. So the biggest one is OSE for Life. So we are a registered non-profit organization in France, and we organize one French championship per year per game mode, so that's 5 tournaments. And we also rebroadcast every World Cup in France. We also serve as a fan club for all friends, for all Team Friends fans around all game modes. Since I took over the organization in 2018, we organized 20 online tournaments, 3 LAN tournaments, not including COE events, and 7 World Cups under my lead. So I want to take this occasion to thank all the volunteers and funders of both OSF Live and COE. I can see some in the crowd. Thank you guys, everyone, for making all of this happen. Part of the hardware used at COE is also from OSF Live. Thank you. Okay, so one of my other endeavor has been development, of course. So, how did I get there, actually? Well, I've been glued to computer screens pretty much as long as I can remember. So, these are actually pictures I've never released before. That's me on my dad's computer at the age of 4 years old. And so I've been glued to these computer screens forever since, playing with them. But by playing, I don't mean video games even. I actually like to do whatever my dad also did on his computer. So maintaining his website, doing Word documents, emails, and Excel. And Excel was actually my first introduction to algorithms and programming, if you can say so. I mean, there's some kind of logic to it. I guess you can understand. I actually started real programming at the age of 8 years old. And I was also self-hosting my own web server at the time. I was hosting it from home. And in fact, the PC I used back then, I still use as my home storage server, holding about 20 terabytes of data. So I'm both a data and hardware hoarder, I guess. Yeah. Next, what I do for OS. So, well, I actually got in the OS team in about 2020, in the middle of the COVID pandemic. I've had issues with my current employer. There were some frictions related to COVID in the workplace. And so I was starting looking for something else, and Pepe actually proposed me to join the OS team to do some infrastructure development. And, well, I accepted. And things also cooled down in my workplace. So I actually work for both my local workplace in France and Pepe remotely, both at the same time. But what do I do for us? Well, this is where it gets a bit nerdy. I do containerization, so I will go into this subject later. Pepe is going to do some roundup of the infrastructure as it is today first. I also deploy those set containers and also manage the Kubernetes cluster. So that's the hardware this software run on. Back to Pepe.
Okay, so let's start by just having an overview look of how things work in the OS infrastructure. Slide. Okay, so this diagram may be a bit hard to read. I don't know how this is coming up on the screen, but this is a diagram of the infrastructure I did like 6 years ago, and I don't think it's changed that much. So I just brought it up to give you an overview of how things are working, but there's basically a whole heap of servers, and they have different tasks. We usually try and keep one task per server. There's boundaries which like split from a security level, what can access what. We run everything behind Cloudflare, and yeah. I can't really go through this in detail. It's hard without being able to point or something. Actually, this thing has a laser pointer. Did you know that, Poon? Can you see that? Yeah, it works. Okay, well, I might use that later. Let's move on. So, most of our servers are now hosted at DigitalOcean. This wasn't always the case. We used to use bare metal servers, dedicated servers, back in the day. I went through about 5 or 6 different data centers, transferring servers from one to the other, and most of the time it was because the data center's technical support not technical support, just server support, remote hands, as you would call it. When something goes wrong, it could sometimes take days to fix issues. And I just got sick of dealing with incompetent, you have like different uh, tiers of tech support where you always start off with the people that really don't know anything and don't have access to the servers to actually fix issues. Yes. So DigitalOcean, it's all virtualized machines, which makes it, I guess, harder for things to go wrong at a hardware level. When they do, it can be automatically migrated to new hardware. And generally, the performance is pretty good. I think I lost the audience feed somehow. That's okay. So, DigitalOcean, they also have really good support. I get replies in under 5 minutes. I do because like we use a lot of resources at DigitalOcean. They give us, I guess, special attention. You get like a dedicated support person, but it's good because that person knows how you're using the service and they're available basically 24/7 for any issues that come up. And over the years, that's helped a lot. That said, DigitalOcean isn't perfect. This is one recent example. It's me bitching on Twitter about DigitalOcean's. They were doing like monthly maintenance on their servers, kind of backup processing, and that would cause our database servers to fall over a bit because the available disk write speed would drop drastically, like insanely. But they have fixed that, so credit to them where it's due. Nothing is perfect in life, especially in the tech world. So this is something I haven't really shown before. It's the cost breakdown of the OS infrastructure. This obviously doesn't include paying people or paying for licensing of music, but this gives you a general idea of that's monthly, how much it costs to run the game. So what can I say about this? You pay for convenience. Stuff like Datadog, which is a monitoring service we use, 500 a month. That's quite a lot of money just for monitoring. And there are self-hosted alternatives. You can run this stuff yourself these days. But the convenience offered by Datadog is absolutely insane. Like we wouldn't be able to get the uptime we get and the insights into the usage of the game and dealing with things like DDoS attacks. It's absolutely instrumental in that. But yeah, a lot of people is probably looking at this being like, holy crap, that's a lot of money. But I think we actually run quite lean for the size of the service. Yeah. ThePoon, do you have anything to say on that? Have you got experience with?
No, the largest service I work for is us, so I don't really have much insight. But I know, well, I can touch maybe on the amount of droplets we have. I think we have 55 droplets. That's a figure we are going to show again later, actually.
Yep.
Actually, some of them are sitting idle. So outside of the stateful droplets, like databases such as MySQL and Elasticsearch, a lot of them are actually sitting idle, and we are working on densifying the workload on these low workload droplets. And this is something Kubernetes will help us to achieve. So these costs are actually going to go down in the following months.
Yeah, and that's actually the next thing I was about to mention is that these numbers here have risen by basically 40 or 50% over the last couple of years due to the pandemic. It's created this huge spike of players and people that have like so much available time which they're spending playing us. And that's dropped off recently, as I'll show you in the upcoming slides. So we, as ThePoon said, we can scale back a bit. The hard thing is that right now, scaling down is a bit hard to do. And that's one of the things that Kubernetes and containerizing is going to help with.
I also want to talk about the bandwidth on AWS. Those who know, yeah, here are some figures. Oh, we haven't actually added traffic for S3 in the figures. But anyway, we managed to save a lot of money on AWS S3 bandwidth by using cache servers in front of our buckets. So AWS customers would usually using the service called CloudFront. But we're actually deploying our own reverse proxies in front of the buckets. And by managing this kind of service ourselves, we manage to save a lot of costs. But we are actually going to come back to this subject with other examples later.
Yes, and one of the things to mention is obviously using Amazon CloudFront is better because they actually serve the resources closer to the user. But we do have Cloudflare doing that on top, so it's kind of like we get around it in a way. So this is some general stats. I've just gone through and added up all the different resources we're using across the board. As ThePoon just mentioned, I haven't put bandwidth on here, but you can see the general droplets of the number of basically virtual machines we're running. And yeah, whoops. Lots of RAM, lots of SSDs, lots of CPUs. We use OVH for beatmap mirrors specifically. So that's where all the hard drive capacity is. We don't use SSDs for those because there's just so much data to store. So that's 22 terabytes of cache across 5 mirrors. And we do have a user provided mirror in Australia as well. I guess I think the guy that provides that is in Twitch chat right now. But yeah, that's how we serve beatmaps efficiently. And Amazon S3 is where we store things like user replays, beatmaps, anything we need to make sure it exists forever. So there's a lot of data stored there. Replays is actually 5 terabytes, which is insane if you think about it. Yes, and I try to run servers at like 50 to 75% load. So there's always a bit of overhead room to handle any load spikes. But right now we're running it closer to like 25% because of the reasons I mentioned earlier, the pandemic load. So this is the database. We use MySQL, and there are a lot of rows stored. So 1.6 billion scores for OS mode, and then like 57, 78, 253 million for the other modes, 29.6 million users, 543 million messages, and that's just for 6 months because we throw away old messages, 30 mil forum posts, and 2.2 million beatmaps, including deleted and graveyarded. So in total, the database is using 1.8 terabytes. About 800 of that is being used for migration to the new score storage tables, which is what we need to allow for both laser and stable to exist next to each other. And I'll get into that further in the follow-up slides. We're basically moving all the existing data across to new data storage. And that's kind of why things are taking a bit of time. And these numbers don't add up to 1.8 terabytes because there's a lot of other data which I haven't put in this table. This is just the stuff which I thought was interesting. There's a lot of historical data, things like user play counts or logging, lots of weird stuff that you wouldn't really be interested in.
I want to add
What other?
actually, oh,
Yeah,
sorry. I want to add actually
go on.
the data that is required to process the PP of every scores, especially in Mania, due to the amount of possible mod combinations with all the key mods. These actually take quite a chunk of space in the database.
Yes, I meant to add that to the presentation. I forgot to, but there's like, so there's 2 million beatmaps, but the rows for storing difficulty of those beatmaps is like several hundred million, and it's like 80 gigabytes of data just to cache all the star difficulties and all the max combo and all the weird attributes that we need to handle the different mods. And with laser, there's like insane numbers of new mods, so we can't really store all that. So we're having to figure out better ways of handling difficulty of mods and that kind of thing. There's a lot of challenges when it comes to laser. And speaking of challenges, let's go through a few of the challenges of managing infrastructure in general. So I've just got a few graphs here, which I've taken out from things which went wrong or weird events which happened over the last year or so. This is where a popular player came back to the game, and everyone jumped on and started watching them. So you can see like load spikes from that. And one thing I'll mention just as an aside is the older pieces of the infrastructure, like the old website, they were really easy to scale because they had so few moving pieces, so few dependencies that I could just like deploy more of them. With the newer pieces of infrastructure, it's a bit harder. This is an example of a load spike. You can see the CPU kind of spiking up here. And that's just from us running processing. So like rerunning star rating processing or difficulty calculation, that kind of stuff. That can actually have an effect on um, the servers which the users are hitting. So you have to be careful not to cause outages from doing stuff yourself. What's this one? This is a case where someone that was using the API, the public API, to run something like a Discord bot suddenly scaled up their usage, and you can see like suddenly the number of requests we're getting was almost double, if not more. And that can be like, if you plan for it ahead of time, it's fine, but it's still like something you have to be aware of. DDoS is probably the biggest issue that we face, or the hardest thing to deal with. This is an example of a recent DDoS where usually we were getting 2,000 requests per second and it spiked at something like 40,000. And that's with Cloudflare in front of us. So Cloudflare wasn't actually protecting us from the full blow. But if we didn't have Cloudflare, that number would be probably 10 or 100 times higher. So we also have our own, I've written my own protections against DDoS, which we run as Nginx modules, I guess, which help. But yeah, it's definitely Cloudflare is a necessary evil. And why is it evil? Well, half the internet is kind of behind Cloudflare right now. So if Cloudflare goes down, um, everything goes down, and that happened recently. So this is an example of just a few weeks ago where Cloudflare dropped out for the whole of Asia, I think. And you can see the spike of people not being able to submit scores in the graphs here, and just the general drop off of players. And that's something that like I wish we could run without Cloudflare because it adds latency, it adds extra moving pieces to the puzzle. It's just something you have to think about on top of everything else. And with some of our newer components, we're actually looking to move away from Cloudflare where it's actually feasible to do so. Things like the Laser multiplayer server is not going to be behind Cloudflare. So
Unfortunately,
go on.
DigitalOcean doesn't really allow us to run without Cloudflare because, well, can you talk about your history with DigitalOcean's DDoS policy?
Yeah, DigitalOcean don't have any kind of DDoS protection, and so far they've been unwilling to implement anything. Other hosting platforms like OVH actually have really good DDoS, and even AWS, Amazon, have really good DDoS protection, but DigitalOcean just haven't been willing to step up to that yet. Maybe they will one day, but you can understand there's a lot involved in making it work. And yeah, it's funny to see DigitalOcean's own website also go down when Cloudflare has issues. So understanding the point of failure is something which is very important. When shit hits the fan, you want to be able to quickly know what has gone wrong. And we rely heavily on Datadog, which is the monitoring service I mentioned earlier, to get intrinsics on what has gone wrong, creating a lot of alerts so you can know when different values go outside of ranges or when they drop below a certain point is very helpful, but also just having enough graphs available to see things go wrong, see things that shouldn't be happening. And yeah, I would say on average, when something goes wrong, I get an alert. I get about 10 alerts to all my different devices. They will wake me up and I will generally have the issue under control within 5 minutes, regardless of what's gone wrong. And with so many moving pieces, it can be quite hard. That's one good thing about running everything myself is I know what is going wrong if something goes wrong. I have knowledge of every single component in the infrastructure. That's one of the reasons I really have wanted to do it myself, not get more people involved in infrastructure until now, and why I was a bit hesitant to even bring ThePoon on board. Yeah. And yeah, one of the other challenges is I want to keep the game running with no scheduled maintenance. And this is just a few examples of other games out there that do like weekly scheduled maintenance of like 3 or 6 hours every week, and it's like, why? Why do you need to do that? I don't get it. It's like it feels slack. So yeah, we don't do scheduled maintenance. I make a point of mentioning that whenever we do any kind of maintenance, it's always like scores are not going to be affected. That doesn't mean that we have zero downtime. As you can see, this is just a screenshot from the last 90 days, and you can see our uptime is only 98.2%, which is by industry standards pretty low. But two things, that display accounts for anything going wrong, even things which aren't necessarily affecting end users. And the second thing is most companies just don't tell people when things go wrong. They don't actually include it in the numbers. So they get 100% uptime, but I know for a fact that they actually had downtime because I see it. Anyway, we try and be as transparent as possible with all the infrastructure things. That said, I kind of just lied because we do have scheduled maintenance. We take Bancho down occasionally. In the recent times, not as much, but because Bancho, which is the chat and multiplayer server for us, because that has it stores everything in memory. So it has it's stateful, as you would call it. It means that when we do maintenance, all the multiplayer games are shut down. It restarts within like 20 seconds, but it's still what I would consider downtime. It's something I would like to avoid. And we are actually avoiding it now in Laser. So the Laser multiplayer server, it actually lets the game client know when it's about to shut down, and when it goes into that process of shutting down, any new multiplayer room which is created on a new server, rather than so the things I have on screen here. In the top is Bancho. That's when Bancho goes down. You can see users reconnect over like 5 minutes until they're all reconnected again. And this is Laser here. So each different color on this graph is a different Laser multiplayer server instance. And so this is over like a week or something. That's why it's spiking up and down. That's just the peaks of each day. But you can see that when a new server comes up, the old server kind of remains and users continue to play until the old rooms actually get disbanded by the users. And I think it keeps the old servers up for up to 6 hours now. We can increase that in the future if required. But yeah, it means that we're not interrupted game sessions, which is one of the, I guess, a personal requirement that I have. I don't like to interrupt when people are having fun. And yeah, on the transparency front, we have all the graphs you just saw. I took them from our public status page. All of this is public. So everything I see, everything I use to see when servers are having issues is available for you to see as well at status.ppy.sh. So I'm pretty happy that we can expose all that. And I think it's probably the most insights you'll get to any game or maybe any web app in existence. Most people don't show this stuff because they're too afraid, or financial reasons mostly. People don't, companies don't like to share their uptime or share when things go wrong. But yeah, it's the reason I do this kind of stuff is it's what I would expect from other services that I use. And even though other services don't do it, because I run this one, I can actually do this stuff. It's cool, right? Recently, we've turned off all analytics, which is why I can't show you things like usage of the website and how things have progressed over the last 15 years. We used to be able to see like the rises in user usage of the platform, and that is no more because I didn't want Google Analytics on the site. I don't want any trackers, and we're at 0 trackers now. That was the only one we actually had on there. But yeah, with the push in general in technology to have less trackers, I felt like it was a good thing to do. So we turned off Google Analytics last year, and yeah, we have less to see now, but I was never really looking at that stuff in the first place, so not much lost. But I do have analytics because one of our internal processes saves statistics every day. And it's not a lot of statistics, but it's enough to get some insights. So let's have a look at that. This graph is from 2012 to 2022 at there's one data point per day. And you can see this, so the top line is, that's the number of scores set per day. So it spikes at something like 1.8 million per day. That's a lot. Yeah. Yeah. And the bottom line is how many active users in the last 30 days. So yeah, you can see the big spike over the last 2 years. And let's zoom in on that. So any guesses to why this happened? ThePoon, maybe you have some ideas.
Excuse me, can you repeat?
Do you have any ideas why we could have had this spike from 20 to 2022?
I don't know.
Maybe a pandemic or something. So I think a lot of people had a lot more time on their hands, and yeah, we saw basically a double, a 2 times increase in the number of scores that were being submitted. Not so much a spike in active users, you'll notice, but and also we've had a drop off over the last year as people go back to their normal lives. So it's been good for me because I spent a lot of time dealing with the increasing load over that time period, just having to scale our services up, and especially Bancho, which wasn't made to handle 45,000 people online at the same time. We were hitting like the number the to run a server, like each client needs to connect to it, and there's only 65,000 ports in existence. So it was approaching that limit, the number of ephemeral ports available. So lots of interesting things happened during that peak, and I'm happy that we could get over it, and I'm very happy that the player count has dropped off a bit since then. But we're still holding out players. Like, even though the number of scores submitted is lower, the number of active users hasn't dropped anywhere near as much. And we've seen, I haven't shown it on this graph, but a lot of users are switching to laser. So the number of laser users is also increasing. So yeah, let's talk a bit about the new infrastructure. And this is what I'm going to refer to as being what we are currently working on, both ThePoon with his moving existing pieces of infrastructure to containers, to Docker, and also moving the way we're storing scores to a new table structure. And that's going to allow us to store old scores next to laser scores and store them in a very flexible way. So we can change things going forward without having to rewrite a lot of data, which has been a pain point in the past. And I guess the theme with all these changes is that it's like everything I've changed is a mistake that I've learned from along the way. And something like just trying to future proof the game basically and make it as maintenance free as possible so we can focus on adding new features to the game, making difficulty calculation even more accurate, adding new multiplayer modes, all this cool stuff which I've wanted to do but haven't been able to because just running the game takes so much time. I think a lot of people don't realize how much time I spend just keeping things running as opposed to making forward progress. So yeah, one of the goals is to keep all existing data intact. Every score matters. Even players which have since quit the game, we need to keep all scores because that's what we kind of um, that's just one of the goals I've had from the start is, and it's something unique to us. We don't have seasons. We don't throw people's scores away. They're there for good. And this graph here is just showing the increase in database data usage over time as new scores come in. And also the spike at the end is us moving all the scores over to the new storage structure. So you can see it almost double in usage. That's because we are currently duplicating the data, moving it to the new format, and eventually we're going to start reading from that new storage. Right now, we're just doing it for testing purposes. Okay, I'm going to get a bit more technical, but hopefully you can follow along still. So this is how we stored scores until now. It's in a MySQL table, and you can kind of understand what's being stored here just from the keywords on the left in white. You can ignore the red stuff, that's just MySQL commands and stuff. But yeah, this is how we've stored scores. And So get that in your mind, because I'm going to switch to how we're going to store them going forward, which is like this. So you might notice it looks a lot simpler, and a lot of things are missing from this format. So yes, they are. And why are they missing? Because of this little thing in here. This is like a JSON data blob, and we are storing all the actual statistics and stuff, everything which is required to calculate a score, show the accuracy. They're all inside this JSON blob. And why have we done that? Well, I wanted to make sure that scores are easy to migrate to new storage backends if we ever want to. So if we decide not to use MySQL, or we want to send these scores to the game client, or use them, send them to people using the public API so they can process the scores further. That's more easy to do if we're not using MySQL columns for storing different things. Also, if we want to add new things to the score, say we want to store the hit errors per hit object. That's a very big one. I don't know if we'll ever get to doing that. There has been a lot of requests to make that happen, just to make PP calculation very accurate. But yeah, putting it in JSON means we can add to it easily. Rewriting database tables takes a long time. So for instance, the OS scores table takes about 8 days to rewrite if we want to make a change to it. And during those 8 days, everything slows down because it's having to read and write that data in the background. Yeah. So this is what inside that JSON blob looks like. And this is where you actually see the old pieces of the score come back into play, along with new pieces that you may not have seen until now. So because in Laser, we are doing scoring a bit differently. In the previous version of scoring, it was actually impossible to calculate the total score after the fact, because combo is calculated at the point in time where the combo is incremented, and that is not stored anywhere. We don't know where the combo breaks are in the map. We can't actually calculate total scores. That's a number which is stored to the database, but we can't remake it. So from a data manipulation perspective, it's suboptimal. We want to be able to calculate total scores from the statistics which are stored against the scores. And from a user perspective, it's harder to understand. You see a total score and you can't actually gain much from that. It's hard to compare. Like, it scales differently with different bitmap lengths. It doesn't really tell you where the combo breaks were in the map or anything. So we've tried to simplify things down in the new scoring system in Laser. And that involves basically doing away with the whole point in time combo break logic. And yeah, I won't go into too much depth here, but I will say the mods stored here allow for new mods to be added very easily, and also settings against the mods. So in Laser, we have the ability to change the double time rate in double time to not 1.5, but 2, or anything else really. That is all stored inside this JSON. And we couldn't have done this using the previous score storage. Another goal is offline processing. So when we run, just on the right, I've shown the previous time we did a score recalculation due to PB changes. When we do that, right now we have to do everything online. And that means that there's, as I mentioned, it has overheads in the infrastructure. So we have to actually limit the rate which it runs in order to not take down the servers. With the new way we're doing things, I've made sure that we can actually do this processing offline. So we can actually pull down all the existing scores, and then I can run it on my PC. I have 32 cores. I could do all the processing locally, then re-upload it and have it propagate out to the servers. That's been one of the themes of what I was trying to achieve with the new structure. Yes. So in theory, the new infrastructure is going to make PP changes easier to apply more frequently. So this is an overview of the new infrastructure as I see it working. The red pieces are things that we haven't completed yet. And one of the main things to note is that we're using queues a lot more. Previously, scores would submit, and at the point the score is submitted, everything is done at that point. So PB calculation, all the statistics changes for the users, it's all done before the server returns to the user. And that's not so flexible. We have to make sure it runs fast. And if it doesn't run in time, the game client is like, what's going on kind of thing. So everything's been moved to asynchronous processes where the score is put into a queue, and then that queue will increment play counts, add medals where the user's made a medal, the user's earned a medal, and then that will also do PP calculations in the background and things like anti-cheat. And then finally, once all that's done, it gets indexed, and once it's indexed, it's shown in the leaderboards. So it makes sure that scores only show in the leaderboards after everything is ready, which is something we couldn't do until now. Previously, they were showing in the leaderboards first, and then everything was done afterwards. Just zooming in on this a bit further. I don't know how well you can see that on the screen, but yeah, it gives you a general overview of where we are at. The red pieces are mostly just like data communication between the various pieces of the puzzle. We still need to do the medal processor awarding medals, and just a few other, mostly glue pieces remain. So we recently, Laser actually came online with real-time score submission just a few weeks ago. So yeah, that shows that everything is getting there. Then the next major thing is going to be switching stable across to also using the new stuff. And there's a bit more to go there. This is just I wanted to touch on the fact that while we make progress, as I showed just now, the red pieces are not ready yet. And the way we're getting around that is I have this all-purpose tool called ASS, um, short for Autobahn Surveillance System. And that does a lot of
Dude, how do you
weird.
expect us, like the audience, to stay serious about this when you laugh about it yourself?
Yeah, it had a really cool logo, but people on the team made me change the logo. I probably shouldn't say it, but there's like a YouPorn logo generator. I use that to make the ASS like Discord logo. So every time it sent a report, it showed that. But apparently that was inappropriate for our internal networks, so I changed that. But anyway, this is a tool which does things like moderation tasks or anything I need to do, any batch processing. I've got all these different scripts which have access to the database, have access to S3, all the different pieces which we have to potentially deal with when things like adding new featured artists. That's also done through this tool. So it's a kind of all-purpose, you know, tool to make things happen. And this is just an example of me like replacing one of those components which wasn't made yet with a single command. So I'm just like running a bash script, which is like looping over this command to mark scores in the correct state if the score is a pass. And this is using all the new structuring I showed earlier in my slides. And that could run over, so there's currently 43.7 million laser scores, and it runs over that number of scores in about 20 seconds. So pretty fast, pretty cool. And this is just another example of one of the tooling components I made while working with the new infrastructure stuff. This pulls from the DigitalOcean API, gets all our database servers, and shows me how much disk space is being used on them, because we are constantly testing new approaches to storing scores. We need to make sure that we don't get too close to running these servers into the ground in terms of free disk space. So this command, I run it once and it shows me all the disk space outputs in a single go. So I find it really cool to make to make sure to keep optimizing your workflow as a developer. And anything you see yourself doing multiple times, just optimize it, make it easier for yourself. Okay, as I mentioned, laser scores are now submitting in real time, processing in real time. They actually, the individual scores get PP allocated. It doesn't add to your user total PP, but it does increment your play count. It shows on your history, a few other things. Yeah, but we're getting there. It's within reach. It's taking time, but I think it's fine for it to take time because, and I know Laser's been going for like 5 years now, but people, like we're still maintaining the old systems, right? And there's new beat maps coming up. People are making tools on my behalf where like the stable editor has issues, but people are working around it, and I'm grateful for that. I'm grateful that we have the time to do this properly, because once we get all these pieces in place, we're going to be able to make faster progress. And you can already see that if you look at the recent laser updates. We're making some pretty insane progress. Yeah, so what is my next slide? Okay. Let me go back. So yeah, what I wanted to say to end this out is that we're getting there. We're currently in the process of doing like the final stages of performance testing with the new infrastructure, making sure we haven't missed any data in the new score structure. Smoogie Poo is currently working through a final pass on that to make sure everything's there, everything's in a good state. And then we need to export all the existing scores again to the new structure. That takes about 5 days. We've done it like 3 or 4 times now, just as a test run. And yeah, we have a soft deadline of making this happen before we run out of basically the existing score storage has like a maximum it can get to before it overflows an integer value. And you may have seen like people made a countdown site, which is like how long until OS explodes. Nothing's going to explode. Like I have a backup plan if we don't make it in time, but that's our soft deadline, and it's coming up soon. And yeah, I think we're going to make it. Touch wood. So this is where I segue into what ThePoon is going to try and talk about. He's going to try and tell you what Kubernetes is and how Dockers and images and containers and pods and nodes and helms all relate together. I don't know how far he's going to get there and how well he's going to do. But yeah, to end up, one of the goals with all this new infrastructure is splitting things out into smaller pieces. And in the screenshot, you can see our current Kubernetes deploy where we're starting to do that. And this is the kind of thing where if I was doing the infrastructure on my own, I don't know how far into this I would get, because I just don't have the time to make everything by industry standard, I guess you could say. I have to take shortcuts along the way because I have very limited time, even though I spend all my fucking life working on this project. Like, yeah, there's only so many hours in a day. And I also want to finish Laser, the client. So yeah, ThePoon has been very helpful so far in getting infrastructure up to speed, making things so we can easily make changes, easily redeploy components if they fail, easily scale components. And yeah, take it away, ThePoon.
Thank you, Pepe, for this overall overview of the OS infrastructure and the challenges we're facing today. How many of you guys are familiar with the concept of virtual machines? Can you guys raise your hands? Okay, that's quite a lot. Okay, so virtual machines are a pretty straightforward concept, I think. So it's essentially another computer inside your computer. So say, for example, you run Windows 10, but you need to run an older game, or you need to do some development work. You might want to spin up a VM, a virtual machine, with another operating system. If you're a developer, you might want to spin up a Linux-based operating system in the virtual machine. So containers are kind of slimmed down virtual machines to give you a conceptual idea. So they run much more lightweight since they actually share the kernel, so that's the part of the operating system that interfaces with your hardware. They share the same kernel. They just use isolation features to make them run separately and concurrently as a virtual machine, but much lighter as a result. The advantages of that is that containers run much more lightweight, because when you run virtual machines, you actually have to emulate the hardware. So for example, if you use a virtual machine on your computer and you actually want to transfer files to and from it, you have to emulate a network card, which can actually add significant overhead at high bandwidth. So by utilizing the same operating system under the hoods, we are bypassing the limits of emulating hardware. And that goes for pretty much every hardware component that you may find in a PC that you would emulate in a virtual machine. Another advantage is that since you don't need to store the kernel for all these containers now, the images also go much lower in size, which make them more portable and easier to use on both production environments and developer machines as well. For example, OSWeb depends on a lot more components than it used to. With the new core processing pipeline, there's even more components that OSWeb depends on now. So OSWeb is the project holding the new OS website that we have been using for a few years now. Thanks to these containers, developers don't need to set up projects individually all the time to get up and running. They can just run that container and actually get the same code that runs in production, just with different settings for their development needs. One downside of Docker, though, is that you have to share the operating system between your host, so that may be a Linux-based server or your own development machine. So that means you need to run Linux. There have been a lot of programs, though, such as Docker for Windows or Docker for macOS that some of you may have been using. So the downside of that is that you actually run a VM to host your Docker containers. But I mean, if you were already using virtual machines anyway, it's still lighter because you only need to just run one now.
Yeah, I'd say, if I can chime in here,
Yeah?
it's really cool that right now, if you want to get into OSWeb development or something, you can just run like a single command and have a full local setup of the OS infrastructure ready to go at your local host. And Docker makes that happen. It would be very hard to get that set up otherwise.
Yeah, big shout out to the OSWeb developers who have achieved that. And I'm also going to get there later, but I've also set up a similar process, but not to get the developer setup for OSWeb, but actually a production-like OSWeb setup on your own Kubernetes cluster, all open source. Okay, so let me show you an example of the process of containerization that I've been doing for us. Actually, just a few months ago, we were running OS performance in a virtual machine, actually overkill virtual machine, so killing that one saved us some cost. So to get a container up and running, we just choose a base image, so often a Linux distribution, in this case Ubuntu, and it's just basically running scripts, copying files, and setting the right permissions. Oh, and compiling the software in this case, because OS performance is based on a compiled language C in this case. So in the end, so this process is run on every commit. I'm gonna go through that later. And in the end, you get images ready to use that you can use on your own computer, the same ones that we run in production nowadays. So the goals of each image we work on is that they are performant, lightweight, they must support all the exposed configuration settings by the underlying application. So in the case of OS performance, I had to work on a script that you can actually see I am copying on this line. This script converts environment variables, which is a standard way to configure Docker containers, to the JSON file that OS performance is using for configuration. Containers must also allow us to keep integrating with the other services. So even though OS performance is running in an isolated container, it must keep all its abilities to integrate with all the other pieces of the infrastructure, whether it's in a developer or production environment. Yep. Oh, can you move the camera, please? So, with this Docker file, we combine it with GitHub workflow. That is, on every push tag, so that's every release we do, that release usually matches production deployments in the case of us. For every release we do, A server on GitHub checks out the repository, so it downloads all the code that is needed to compile and run OS performance. It sets up a Docker environment, uses Pepe's Docker credentials to prepare pushing the image to both developers and production, and then it builds the image using very simple arguments in this case. OS performance doesn't have environment-related settings on in this case. I forgot what I was going with this, but the OSWeb workflow is much more complex, and we will go through this later.
More complex than we've already showed?
Excuse me?
More complex than we've already shown us? I don't know. Raise hands in the audience if you're following along with this.
I think you can see the audience, right?
No, my feed of the audience froze.
Okay, so do you have anything else to add?
Me? I'll just mention that the OS performance that you were mentioning, that's the old PB calculator, which we've since replaced, but as long as we're running the previous infrastructure, we need to still run the components. So yeah, ThePoon has been moving that across to the new infrastructure for us. Yeah.
Okay, thank you for your insight. So here we have in the OSWeb repository a more complex GitHub workflow. This one is more complex because supporting the different environments we would deploy OSWeb to requires a bit more work. So this image is actually much more meant for production deployments because we have to hard code app and docs URLs. But it's also running more GitHub tags, Docker tags, I mean, because as you can see here at the top, we run through this workflow on both the master branch and tagged releases. In the case of tagged releases, we actually tag it as latest, and it gets ready then for manual deployment. In the case of a commit to master, we mark it as latest dev instead, and then in the second part of the workflow that I'm going to show you later, it will automatically deploy to staging, to our staging environment that is hosted on dev.ppy.sh. It is the default environment that is enabled to laser developers to test around and screw around. It's basically a hosted sandbox environment that everyone interested in laser development can connect to. The OS rules for multi-accounting don't apply there, so it has been useful, especially when real-time multiplayer was being implemented in OS Laser about 2 years ago. And it is still used to this day. So yeah, let's now get to the topic of container deployments. To get these containers running, we have decided to no longer manage the hardware that we run them on. So we prioritize nowadays Kubernetes-based deployments for stateless services. So basically anything but databases that require performant disk volumes. We deploy new components to Kubernetes, but we also migrate existing components whenever we see a need for it. So, as you guys know, the OS infrastructure is quite dating back in time, and sometimes some components need upgrading. And instead of upgrading the current environment for these services, we opt to migrate them to Kubernetes instead, which allows us to reduce the maintenance overhead of these services, because the operating system and container deployments are now managed by Kubernetes rather than humans using, rather than us from the host team using scripts. Um, we are using actually DigitalOcean's managed Kubernetes service. Um, it allows us to reduce our costs a lot by not having to manage the cluster ourselves. So DigitalOcean is taking care of all the operating system updates and integrations with other services from DigitalOcean. Um, most used ones being block storage to add disk storage to our containers for them to store temporary or permanent data. And load balancer to give entry points, highly available entry points to our applications running inside. Um, we also have to use Helm in some scenarios. Um, so usually you would manage your apps running inside a Kubernetes cluster using Kubernetes manifests, such as this one. So going back to the example of OS performance, which is currently processing PP for all OS scores, um, this is a 50 lines file describing the deployment, the Kubernetes managed deployment of OS performance. So as you can see at the top, we just have some metadata, so how to name it and how to label it. Names are unique per namespace, and we use them for lookups essentially. And labels are also used for lookups using key value pairs instead of just a single string inside the cluster. So that's for both humans managing the cluster and automated tools. And inside this deployment, we specify one container that is running of the latest OS performance image. So every time we make a tagged release, rebuild a new image tagged as latest, that we are then deploying it using this manifest. We give some command line arguments and environment variables, which are used to configure the OS performance runner. And then we just have to apply it, and Kubernetes will handle all the starting up for it. It will handle collecting logs. It will handle network traffic inside the cluster. It will handle automatic restarts in case of crashes with exponential back off. So when an application crash, such as OS performance, in this case, OS performance depends on a single other component, that is our MySQL database. So if there is a connection issue with the MySQL database, Kubernetes, well, first the application will crash. Kubernetes will attempt to restart it. And if OS performance just never comes back online, Kubernetes will just continue restarting it, but with exponential delay every time to not put additional burden on the infrastructure. Because when something goes wrong in the infrastructure, we can get cascading failures. So if the MySQL server crashed and OS performance and other services, depending on the MySQL database, would just try restarting and restarting indefinitely and very rapidly until the database is back up, that will actually put even more load in the infrastructure and make it slower to recover. So Kubernetes is what we call a container orchestrator, because it handles all the complications of running containers by its own.
Yeah, and just to butt in here. So I guess giving a like real world example using OS performance of how this has changed how we do things. Previously, because when we do like a PP change, we need to recompile this component with all the new algorithms applied, the new PP formulas, the new star rating formulas. When we do that, we need to recompile the OS performance component on the servers right now, on the server which runs it. And we've run into issues where like the dependencies are different on different Linux distributions. So you try and run the recompilation on the server and it fails. Things like that you avoid completely with Docker, because you're guaranteed things will work. Once you push a Docker image and it's all working in one place, it'll work everywhere. And that's the reproducibility of Docker is really good there. And yeah, the other thing is that we were running, because we make such regular changes to the PP processor and we need to do sometimes manual maintenance on it, we run the actual instances of the PP processor just in like a screen or a tmux session, and it's a bit jank. It worked, and it worked for many years, but it's also not the best way of doing things. So having it in Kubernetes allows us to very easily change to a new version, or if something goes wrong, or if we want to target a specific PP algorithm from a previous point in time, we can just change the the image which Kubernetes is deploying from, and it'll go back to that point in time. It makes it very easy to revert changes if we need to, which was something that was quite hard in the past, or could have been quite hard if something went wrong.
You have a very good point, and actually, containerizing OS performance to alleviate that build issue you went into was actually one of the first tasks I did as a member of the OS team.
Yep, exactly.
Um, yeah. So with this manifest, we have deployed what we call a deployment object to Kubernetes. So I'm going to try and explain as best as I can the inner workings of Kubernetes. So whenever you have a deployment object, it also spawns a replica set object. Replica set is a component of Kubernetes that handles the pods that are going then to run the containers. So replica set will ensure you have the deployment you specified, replicated and healthy the amount of times you specified. So if we go back to our manifest here, you can see right above on line 7, I think it's line 8. On line 8, we have one replica only because OS performance is actually a fairly lightweight service on CPU. So it can compute a lot of scores per second. So replica set doesn't have much job in that case. It just spawns a pod and spawns another one whenever the pod breaks. And whenever we make an update to the deployment object, so let's say we made an update to OS performance and we need to pull out a new image to compute scores using a new PP algorithm, it will then spawn a new replica set alongside the older one, and it will maintain both replica sets until the new replica set is considered healthy. So that allows us to keep service running without interruption in case an upgrade goes wrong, in case of a startup failure, for example. And if needed, Kubernetes also supports version history. So if the deployment goes wrong, whether at startup or later on, we can just, in a single command, roll back to a previous version of the deployment, and then Kubernetes will spawn this replica set again, and whenever this replica set is considered alive again, this replica set will go down, and Kubernetes handles all this container management, replicas management, and upgrades and downgrades management for us. All these pods then run deployed on any node within the cluster. So Kubernetes really facilitates horizontal scaling. So that's when you scale without increasing your individual machine's capabilities, but instead add just more machines in parallel. So you can achieve the best cost per performance ratio depending on the price of hardware at different scale. Yeah. Anything to add, Pepe?
Yeah, the whole Kubernetes is a very hard thing to explain. I think you're doing a good job, but I think most people won't be able to follow because I struggle to follow along with Kubernetes and Docker stuff. It's like it's one of these things which I mentioned earlier to you today, but it's the same as with web development recently. It's just like layer on layer on layer of very simple things, but when you look at them as a stack, it's impossible to understand, and it takes like years to get familiar with all these terms and all the things and how they work together. But for anyone that's like and I know because a lot of people in our team as well, when you mentioned Docker, it's like, fuck Docker, I don't want anything to do with that. But the more time you spend with it, the more it makes sense and actually begins to work well and make you more efficient. So to anyone that like is balking at this and being like that seems like too complex or whatever, it grows on you, and I think it does have a place. And to like approach it one layer at a time, like start with Docker and learn how to just use Docker on its own. Kubernetes is a layer on top of Docker, and then there's like Helms, which are a layer on top of Kubernetes, which I'm still not sure about myself. ThePoon is very keen on them, as you'll probably hear, but yeah, it's
Yes.
complicated.
Yeah, it is. And well, we actually share some discrepancies in point of view, as you've heard. That's because, well, as you said earlier, you were running most of us infrastructure by yourself all the time, and of course you don't have the need. You didn't have the need for such industry standard tools and their advanced capabilities to help you in these tasks. But these tools and all these technologies that are being pushed by larger companies than us, really, is is the technologies you need to adopt as you scale up in your development team and service growth. Because these tools are just industry standards, so you can just hire someone to do Kubernetes work for you, and they will join and be able to help you on the get-go. They won't have to get deep into the code of your app to know how to deploy your app then. To give you an example, I actually don't work on the server side, on the applications, such as OS performance, for example. I've done some patches to OSWeb to make it more compatible with container-based deployments and evolutions of the infrastructure I was doing. But I'm not actually doing dev work on the applications themselves. We just adopt these standards to allow teams to work together and match expectations that we can't match otherwise.
Yeah, I think that's something we can agree on. What you just said makes complete sense. As you scale a team larger, you have to dumb components down, you have to follow standards, you have to add overheads where overheads are required to make sure everyone is on the same page. And it is one way to do things. I've always tried to keep the team as small as possible because I don't want to have to bother with this stuff. It does add overhead, it adds mental fatigue from having to learn all these new systems, which is why I haven't done it until now. But I feel it's like the right time to do it now because we are upgrading components, and it will hopefully make things easier in the long run. And I think it has so far. It's actually helped me spend less time working on infrastructure. Like even if ThePoon stopped working on things right now, I think I would have a better time managing things than I would without. It's just that initial overhead to get everything upgraded and supporting Docker and getting the Kubernetes deployment in a way that you can easily upgrade components, easily push out new changes. That's the hard part.
Yeah, great sum up. Um, so, after having explained to you how Kubernetes manifests, how the Kubernetes deployment manifests work, well, there's actually a lot more going on in Kubernetes, and OS production is a pretty simple app, but let's explore the case of OSWeb. Alongside a deployment to run the app, it also needs ingress points, since OSWeb is directly exposed so you can access it to your browser. It will also need storage and a lot more configuration variables to run. And at some point when you need to deploy larger projects, you need to, and to cater to all the target environments you're targeting, you need to make what we call a Helm chart. So that's a set of Kubernetes manifests that are also written in YAML, the same language we have seen, but with Go templates on top. So these allow you then to write standardized sets of manifests, and then using configuration variables, you can make them run in different set of environments and different set of settings. So let's take another example. If you were to deploy database engine in your cluster, say MySQL, you actually have different expectations depending on the environment you're targeting. So if you're doing database MySQL, a MySQL database cluster for production, you will want actually multiple MySQL engines to run in parallel to support the load and recovery capabilities in case something goes wrong. So you can just spawn a MySQL Helm chart and with replication settings enabled, and it will do that just for you. Whereas if you want a MySQL instance for just development work or a staging environment to test some changes before going to production, you won't need such resilience, and you can just instruct the Helm chart to deploy it with just like one engine running with less storage and less CPU and memory dedicated to it. In the case of OSWeb, we also make use of another feature of Helm charts, which are subcharts. So essentially, subcharts are charts embedded in the OSWeb chart itself, and it allows you to bundle with the Helm chart of your application other Helm charts that are going to be deployed at the same time. And not only that, the parent subcharts, OSWeb, can also pass configuration options to these subcharts. And so, for example, if you today wanted to deploy this OS software stack on your own Kubernetes cluster, you would just need to deploy the OSWeb chart, give it settings according to the deployment you want and the cluster settings you want, and the parent chart will, on its own, configure all the subcharts to integrate with your parent OSWeb instance. And so, in just one command line, you can now deploy OSWeb with almost all its feature set. So since we deploy Elasticsearch, you will get search features. Since we deploy OS notification server, you will get real-time chat notifications inside your web browser. And the list goes on with, for example, OSQ score statistics that is handling with OS Elastic Indexer the scope processing pipeline. This OSWeb Helm chart is being deployed to production as we speak, but it's also mainly used in the staging environment right now. The staging environment is actually, let me check, yeah, is actually just running with 75 lines of configuration. To give you perspective into this, OSWeb itself has 293 configuration properties. Just OSWeb itself, not including all. It's gonna be hard to go back. Not including all the subcharts. Just OSWeb itself, only OSWeb itself has 290 configuration options. So I've done my best to manage OSWeb deployments easier using this technology, and this simplified configuration scheme allows us to update staging very regularly. So dev.ppy.sh is actually upgraded on every commit down to the OSWeb master branch. And actually we also have, I believe, yeah, the GitHub pipeline for this. So once the image is built, it then runs either push to production or push to staging job. And in the case of push to staging, it creates a job in our Kubernetes configuration repository to deploy the newest Docker tag. And this is how we manage the staging OS web environment nowadays. Entirely automated. And yeah, this Helm chart is open source, so if you ever want to play with a Kubernetes cluster, if you want to get into DevOps, you can actually try and have fun with the Kubernetes manifest we have ready for you in this repository.
Yeah, so TLDR, if you want to set up your own private LAN OS server, you can do it in one command, potentially, right?
That is exactly right. The Helm chart not only
It only works
handles
with Blazor.
deploying the components, it also handles initializing databases, so both MySQL and Elasticsearch, and also some seeded data, so fake data to test the various features. You could also, it's not implemented yet, but you could also import dumps from data.ppy.sh in your instance, and you could get all bitmaps available for example, as you said, a LAN party. So these dumps we are producing on data.ppy.sh are monthly. These are usually used for PP algorithms experiments for the developers. So they can run their own modification of the PP algorithms on a very wide range of bitmaps and users and scores to test out their changes, but it has also other uses.
Yeah, so what I'll add to this is that one of the big things that was important to me in rewriting the game client as Laser, and also from an infrastructure perspective, is making sure that us can live on beyond me. If if anything was to happen, I want to make sure that people can easily reproduce the infrastructure and the game. So making Laser open source, so anyone can take over if they want to, and also having the infrastructure redeployable, means that anyone can potentially set up their own server and have take over the full load of us if they wanted to.
Okay, so we are now going to talk about Kubernetes cluster management. Oh, the title is a bit cut out. So with all this development work we have been doing, we also need to have them deployed and running for both our staging and production environments. So for this, we are, as I said earlier, still relying on DigitalOcean. They provide an awesome managed Kubernetes service that we rely on. And on Docker, on DigitalOcean Kubernetes clusters, on DigitalOcean we have two clusters. We have a production and staging clusters. So the benefits of having two different clusters is that I can test out changes without breaking production, as has already happened. And to do this, to manage these two clusters, we use a single Git repository. So we use infrastructure as code standards. So the manifest file I've shown you and the Helm charts are one step of this. They allow you to deploy components in Kubernetes, but we also need repository to store all the configuration to run our own environments. So this repository contains our manifests files and Helm configuration files. For the common components that we share in between the two clusters, we actually use symlinking. So this actually ensures that for the non-application components that we run in our clusters, they run the same. So we run the same ingress engine stack. In both clusters, we have two ingress points. We have a non-Cloudflare one, so that's for applications that we wish to directly expose to the user without going through Cloudflare. This ingress is currently used by the Laser multiplayer server. And we also have a Cloudflare only ingress path with different configuration because due to proxying through Cloudflare, we need to handle stuff like not allowing users to access the server directly and restoring the IP address where the initial connection comes from. This is essential for our security practices. We use scripts to apply all the changes to our cluster. We don't actually have much automation in that part yet. We don't have that confidence for now, except for the staging environment where, as I told you earlier, on every commit to the master branch of OSWeb, a deploy job is triggered from GitHub. Something I want to touch on, the production cluster that I mentioned earlier, it allows us to be more cost effective. So right now on the production cluster, we are running on 3 nodes. That allows us, and those 3 nodes are enough to actually run 15 production applications. So instead of using 1 node per application, as we used to do in our old deployment model, we have managed to run 5 applications on single node. So they are all varying size. It's kind of, take it as an average. But it allows us to be much more cost effective. Okay, so where we are, my main task right now with the Kubernetes cluster is getting it ready for actually migrating OSWeb to the cluster. So the Helm chart I've talked to you about earlier is actually in a great shape right now to allow us to deploy to production. And we have been testing running OSWeb in the cluster. And to do that, we have added configuration options to our front load balancer using cookies. So using a private cookie, we can switch routing from our current OSWeb deployment to the next generation OSWeb Kubernetes deployment. And I've been running with this cookie on my computer for a week, and I am testing all the features as a user in production. Once this testing phase is, sorry?
Sorry, did you say we're using CookieZ to run this infrastructure? Do we have his consent?
Do you want to release the cookie?
Never mind.
Oh!
I'm just joking around.
Yeah, okay,
But
sorry.
basically we're at the final stages of being able to deploy the whole of OSWeb using the new stuff that ThePoon has been working on, is what he's saying. We're almost there.
Okay, well, to give you some context, guys, the speakers are facing towards the audience, so I cannot hear Pepe that well.
Right.
Nah, keep it as is. Don't worry that much. Okay, so once that testing using cookies on the OS team ends, we will actually be slowly deploying OSWeb to the general mass. So we will be doing a stage rollout. So at first we will direct 5% of the traffic, for example, to the cluster, to the new cluster. And as we go on, we will be able to turn off servers handling the older infrastructure until we reach 100% traffic on Kubernetes. We are also going to experiment with automatic scaling features provided by Kubernetes. So Kubernetes provides configuration objects called horizontal pod autoscaler. It watches for CPU and memory usage of your containers, and if it reaches some thresholds, some user-defined thresholds, it will spawn more containers in parallel to handle the added load. So, for example, if we are on a day during a weekday, we'll have less traffic than on weekends, for example. So Kubernetes will adapt and scale down the application a bit. And whenever we reach the weekend, it will spawn more containers again. And we can combine this with DigitalOcean's autoscaler. And DigitalOcean doesn't monitor the containers load. It will monitor the nodes load themselves. And if it sees that the nodes powering the containers of a Kubernetes cluster are overloaded, it will then spawn new nodes. Thanks to DigitalOcean's hourly billing, that allows us to, for example, run with 1 or 2 more nodes on the weekend automatically as we need. Or if a popular YouTuber, for example, makes a new OS video that goes viral and we get a new load spike for the next 48 hours, Kubernetes and DigitalOcean will automatically scale up and add more server capacity to our cluster to handle the added load.
Or, if there's another pandemic.
Sorry?
Or if there's another pandemic, right? And we get
Oh,
two
yeah,
times the load suddenly.
that will also be handling the pandemic, yes. If we get a new one.
Yeah, so
I
in theory,
I don't mean to curse.
Yeah, touch wood, it never happens because, oh my god. But in theory, those costs that you saw earlier in my slides, we can reduce them a lot with the changes that we're making here. And maybe like something like 30 or 40% less because we are currently not using the full capacity of our servers.
Another thing I've been working on the Kubernetes cluster management is deploying our self-managing services. So you may have heard of, I think Sentry is the most popular one of the two. So Sentry is an automated bug collector. So whenever you have an issue in your OS web pages or in OS Laser, if you get a crash in OS Laser, for example, it gets reported to us by the way of Sentry. And Sentry exists in 2 flavors. You can either use their managed service, which you pay monthly and they just host the service for you. Or, well, their application is actually open source, so you can actually deploy and manage it yourself. So the premise of the self-managed services is mostly for smaller teams who don't want to spend time maintaining the application themselves. But for us, we actually have enough growth that handling these services ourselves, hosting them ourselves, and maintaining them ourselves, even though we are not the original developers of Sentry, can actually net us less costs. So to give you an example, I run a simulation. With Sentry right now, we are currently handling 400,000 errors per month. So that's errors reported by your game client or your browsers. And 3.5 million transactions. So a transaction is when you go on the OS website, the OS web code base will actually monitor the performance of the page delivery to you. And we do this for, I think, 5% of the requests, or no, 0.5% of the requests.
0.5%, yeah.
Yeah.
It has quite a big overhead, so we don't do it for all requests.
Yes, that is why. It is a debugging feature in the first place. And so running simulation with this number, Sentry.io would cost us $250 per month. And we think it's quite expensive. So 3 months ago, actually, I think it's actually really 90 days ago, we deployed Sentry to our own cluster using a community maintained Helm chart. So we have actually done fairly little work on deploying Sentry. We just took the Helm chart and changed our configuration settings to adapt to our load and storage requirements and cleanup policy because, well, with 400,000 errors per month, it quickly takes a lot of space, so we need some cleanup. Well, it uses us around 0.8 CPU core, 8 gigabytes of RAM, and 150 gigabytes of block storage. And running this on DigitalOcean costs us $78 per month. So that's only on the compute and storage, not on maintenance. But with a service like us that has a long-term view, um, this only took us like maybe 10 hours to set up, and I spent some time, maybe like 1 hour per month, adjusting several settings or looking up at the storage requirements or handling minor upgrades. And it nets much cheaper than using the self-managed service. Um, one, and it actually has enabled us to actually use more features of Sentry, because we were not willing to pay that much for the Sentry service. So we were logging, so we had turned off logging of many errors from many projects that we considered less important. We were not actually running any performance monitoring on OSWeb. And I think the OSWeb developers have been able to squash quite some bugs since we added Sentry, right, Pepe?
Yeah, I guess so. Yeah, but definitely like the reason why I asked ThePoon to run self-hosted Sentry is because they keep raising their prices. They're kind of a dick company. And I wasn't willing to, they're like raising the prices for the same service, like doubling each time. And it's the third time it happened, I think, recently. And I was just like, that's enough. So two things. We're actually paying more for Sentry now, but as the Poon said, we're able to log a lot more errors. So we had lasers set up to report errors to us for the longest time, but it was disabled because it just reported too many errors, and Sentry has a quota, and our quota was set low enough, so we only had to pay like $30 a month. And if we reported all of lasers errors, it would have added up to like $200 or $400, and it's just like, what are you what are you paying for there? But credit where credit's due. The only reason we've been able to self-host Sentry is because all of their stack is open source. So props to them for making it open source, because a lot of companies don't do that, which means you're locked in and you don't have an alternative unless someone writes their own.
Another advantage to self-hosting services is, imagine if, for example, Sentry as a business went down, we would need to migrate, and potentially on a very short deadline, to another service. Whereas with our own managed Sentry instance, if Sentry goes out of business, well, we can still keep running it, and surely since it's open source, someone or some company is gonna pick it up and continue development on it. We have applied, we have also done our own deployment of TeamCity, but this is for different reasons. If I remember, Pepe, you told me that it's because the TeamCity cloud options are not very well suited for open source projects.
Yeah. So TeamCity is like a continuous deployment, continuous integration package, and we generally use GitHub for CI. But I wanted to get TeamCity running again because it's got a lot of features which are missing from GitHub, and it has really good configuration. Like there's just so much flexibility with what it offers you without having to go through configuration files and potentially make your own pieces to get the CI working how you want. So I used to run TeamCity as a self-hosted thing, not using Docker, not using Kubernetes, but we ran it back when we were doing more active development on the OS client. And I shut it down eventually because it was just too much involved in managing it myself, and it's gotten a lot better, both because we're running it on Kubernetes this time and also just because TeamCity has improved over the years. But yeah, their cloud offering, they do have a cloud offering, but it's like you pay per user that commits to the project over 10 times a month. And for us, that's like a lot of users. So it would have been like hundreds of dollars. And the primary reason we wanted to start running TeamCity again is so we can actually make the test runs run on our own hardware. So what we're doing is we have TeamCity running, but then we have our own build agents which are running on like my PC and Smoogie Poo's PC, and because of that we can actually easily locally see what's going wrong. We're tracking a lot of errors in Laser, which are like very edge cases that are hard to solve. Like on certain hardware, the game can just freeze up, as one example, because the audio driver on Linux gets into a bad state 1 out of 10,000 times. And trying to track down the root cause of that using GitHub issues is GitHub Actions, which is GitHub CI solution, is very hard because you're not able to SSH. You can't access what's running on the boxes. You just have to like add logging and hope it shows you the right thing. But because we're running locally using TeamCity, we can actually shell into the box and get a core dump, or we can attach to the running process and do further debug ourselves. It's super flexible. So that's what we're using it for. We have a schedule set up in TeamCity to just keep running builds 24/7. And it's caught so many errors that we haven't found anywhere else. Like we would have never found these bugs, and it's good because we catch them before they go out to users.
All right. And that concludes our infrastructure dev talk. Pepe, I think you have some things to tease us about. I will leave you the last words.
I don't really have much to. What are my notes on this slide? We're upcoming to 15 years, very soon. So we might have some cool stuff coming there. I can't promise anything, but yeah, it's cool. I want to say thanks to everyone for sticking with us for up to 15 years. I know some of the players have been around that full 15 years, and they're still around. Whether they're playing or not, they still exist in the community, and it's amazing. So thanks for entrusting us to run this service for you and continuing to enjoy it as much as you can. We have a lot coming in the future. Laser is getting there, as anyone who's tried it can definitely attest to. We still have some performance issues to figure out, and getting mobile support up to scratch, and touch support in certain game modes isn't supported well. Getting score submission completely online, we're getting there. We're very, very close, and we've started to do weekly change videos on the OS YouTube channel about Laser, and that will continue each week. Thanks to Pitchy Fat for that. He's doing an amazing job there, and he's doing an amazing job across the board. Yeah, so we're just getting warm up. There's lots more to come. Thanks to ThePoon for his contributions to the infrastructure. It's so far been really helpful to me, having someone else on board that I can pass tasks to when I just don't have the time to do them myself. A lot of stuff is getting done which would have never gotten done otherwise. And yeah, thanks to everyone who's still watching. ThePoon's section was very technical, and props to anyone who got through that, especially if you understood most of it. And to everyone at COE, I'm sad I couldn't make it there this year, but hope you're having an enjoyable event. I'd like to see more photos and video from around the event floor. Like looking on Twitter, I've only seen memes about the food being bad, but I don't think the food is really bad, right? So I'd like to see some of the actual food provided there. The good side of things, and also just like some shots of the BYO area and the arcades. I'd like to see more of the event. We're not getting enough of that, so yeah, let us see more and enjoy yourselves. I'll make it next year.
Thank you, Pepe. Okay, we have, I think we have 10 minutes for some questions. Do we have any question in the audience? Okay, come here, man, go. So it can be on any OSDev related topic. It doesn't have to be infrastructure.
I've got two questions. First question. So I've noticed that OS has been moving towards greater transparency in recent years. Were there any inspirations for this, for you to go down this route, or was it just the logical next step?
Yeah, good question. I've always been about transparency, and I guess the only reason I didn't do it from day one is that there's certain overheads that come with being transparent. You have to be a lot more aware of what you're doing. You can't take shortcuts. You can't hard code keys for stuff into the code, and you have more of a sense of responsibility for what you're pushing out there, because other people are going to be potentially reading it and potentially using it into the future, especially for like open source open sourcing the project, where someone may make a fork of it or use our framework for a different game, another rhythm game or something like that. Yeah, no real inspiration. It's just been something I've always strived for. And like to add on to that, I've always also wanted to be more transparent with things like financials, but that's a whole nother story. Like the amount of time that would be involved in making that happen. So like in this presentation, I showed the infrastructure side of financials, but I'd love to share the licensing side and running company side. I think there's sharing stuff for me, being transparent, it allows other people, other developers to follow along and either just enjoy seeing what we're doing or learn from it and maybe help them in their educational journey to get a job or whatever.
That makes a lot of sense. My second question, slightly morbid actually, but what would happen, or rather, what would you want happen to OS if you were no longer able to work on it in terms of leadership and growth?
Yeah, it's something I do think about quite often. Like in our current state, if I was to get like hit by a bus or maybe a motorcycle, that's a common. If anyone watches Japanese dramas, the amount of times people die from getting hit by a motorcycle is just like off the charts. They would just stop as the motorcycle hits them, like freezing in front of it until they die. Anyway, if that was to happen, yeah, one thing is like, do we have all the components in a way that someone can already take over? If people didn't have access to my servers, like ThePoon doesn't have access to every server, neither does anyone on this team. I think backup plan is like, I think Nekodex has the most access of anyone. He can like potentially get into everything and give other people access as required. But yeah, there's two paths it can take. Like potentially someone could take over using our existing infrastructure and somehow keep things rolling. That would be pretty cool to see, but also I don't know if that would be feasible to happen. It's just like I have so much stuff which I still take on myself, which would just stop if I wasn't doing it. Especially on the financial side of thing, the running the company. Yeah, but the other path that it could potentially take is that now that we've got all these components open source, someone could just set up like their own server stack and run it a lot more lean. Like, and people do it. There are private servers out there. I mean, it's no secret that other people are running their own servers. I don't have anything against that. And that's one of the things with like the Dockerizing everything, containerizing everything, is that it makes it easier for people to run that if they want to. And it could be for like private events or it could be for a small community or whatever. I think that's fine. And someone could potentially like if the servers were to go down, someone could take over for sure. Just running their own setup, running the Helm charts which ThePoon has worked on. And I'm sure a lot of like if someone that had a good sense of leadership took over, I think other people from the team would probably support them. But yeah, I don't really have a backup plan yet, and I'm gradually working towards that over the years. But it's hard. It's a hard thing to do when you're also pushing like so much forward development in the project.
Working on a backup plan is actually a titanious task because, well, as you've been running everything as a one man for such a long time, there's so much stuff that feels like implicit for you and that has never been documented that whoever needs to handle that backup plan doesn't know about, and that's on all fronts. I'm speaking about developer here, but also it can also be legal stuff or licensing stuff.
Yeah, yeah, and it's like another thing is I can't think of a single person I know who would be interested in or I would want to take over the project just because like I think it would destroy most people, destroy their lives and potentially their mental state. There's just so much involved, and I,
Yeah,
I don't know how to put this, but yeah.
yeah, props to you for keeping the game running for so long. Do you actually ever see, that's going to be my question, do you actually ever see your passion for the game dying down?
From me or from the community?
From you?
Oh, No, as long as there's as long as there's people playing the game, I don't think my passion's going to change. I have other stuff I would love to do if I didn't have us, but um, my brain like gets fixed on one task and like I have to see that through. So I don't really have an option of switching away to a different game to work on something else. And that's like I don't see that as a bad thing. I'm enjoying every day that I work on this project. So yeah, no, I don't think my own passion for it will change, especially with laser. To me is like my dream project. We've done so much amazing work on it, and we have so many new contributors coming in by the day, and we're just making really good progress. And like ever since I was a kid, I've always been like interested in uh, wanting to make like a UI, an operating system UI, and it's kind of what we've done with Laser. Like it's its own OS in a way. It's everything's embedded in it these days, and yeah, it's really fun to work on, and the team is really cool, and yeah.
Okay, thanks for your answer. Do we have any other question in the crowd? Okay, it looks like we are out of questions. Let me get one from the chat quickly. Um, we got one. Well, we got many questions about stuff like when are some features of Laser coming? I think you guys can follow that in GitHub discussions and issues. One interesting question that we can doubtly ask to Pepe related to maintaining us, I think, is one question from Cowboy Boy. Since you had some monthly costs up on the screen earlier, um, what are the total monthly expenses for us if you're willing to share that? Or I guess maybe give us some insights on how much us spends on licensing every month for, um, yeah.
See, the funny thing about that is like, I really dislike dealing with money. Um, so much so that like I probably because I still do most of the accounting myself. Like I do have an accountant which does a summary and submission of my tax reports for me, but I don't actually know. Is the real answer because I pay as little attention to that as possible. As long as I see like numbers not going down, as in we still have bank balance, then shit is okay.
I
So
mean,
what I can go
that
on.
might sound crazy, but I mean, you're not an accounting guy after all. You're only just a developer.
That's one way of looking at it, yeah. But I also manage two companies, and a lot comes with that, which it's stuff that I don't talk about because it's mundane, boring shit. But yeah, what was I going to say? What I can say about monthly costs is that we put every spare dollar back into licensing, and I'd like to hear from Pishy Fat like how he's actually handling that because he's dealing with so many artists every month, like especially over the COVID pandemic, where we had like a because we had so many more users coming in, we also had an influx of money, and actually managing to spend all that on licensing is huge props to Pishy Fat. And yeah, I don't know how big our backlog is of featured artists, but yeah.
Yeah, and also big shout out to all the other contributors of Us Laser. Yeah, Pishifat is in crowd. Can we get a round of applause for Pishifat? Yeah. Also, big shout out to all the other contributors, open source contributors, and other members of the Us team. Can we also get a round of applause for them? Okay, I've got one closing question for you, Pepe. Very interesting questions in chat. When is Laser gonna be on the Us download page? It has been released for years according to you, but it's still not on the download page. What's up with
when you
that?
said when you said interesting question from chat, I thought you were going to ask the other one, which I saw, which was never mind. Yeah, I would really love to put the laser download page on the laser download link on the download page. And again, the only reason we haven't done that is because we don't really have a good design for it. Like it's very hard to explain to users that. Yeah, chat got it. It's very hard to explain to users the differences between stable and laser, and like I think we need maybe, you know how like sites do those comparison tables where you see what features each thing has, and we can update that as we get the newer features implemented in laser. In fact, I think like maybe proper PP score submission is one of the only major remaining pieces.
I agree.
I recently did a pass on all the like major epic features that we still have to implement, and we only came up with like 10 of them or so, and most of them were related to score submission, things like having replays stored correctly, having proper anti-cheat. There's a few remaining pieces. I do see like I don't want to curse it or anything, but I'd say by the end of the year, we definitely will have laser giving PP in some cases, if not all cases. So, like, one of the things I'm thinking is to get the ball rolling because I want to keep the momentum up with laser. And one thing we can do is, for instance, make all scores below a certain PP value count. Just so, you know, even if we don't have the high level anti cheat that we do in stable, we can still allow new players to come into the game in laser and get that sense of progression for the lower levels of things where things don't matter so much. Even if someone was to cheat on like a 2-star difficulty, who's going to see that? No one. What are they even doing it for at that point? Anyway, yeah, definitely for a download link, I would like to have it up like 6 months ago. We just need to get a better design for the page going. And I've asked Flight about that, and I've asked some other designers because Flight hasn't given it to me. But the other designers, we got one back and it wasn't great. So if any designers are out there that want to like make the download page show laser and stable, then hit me up with a design for it.
All right. Thanks for your answer to this last question, Pepe. This is going to be the end of the OS Dev Talk of COE 2022. Thanks everyone for tuning in, whether you stick through the entire thing or just listen to some bits. Before closing it here, I want to mention the upcoming schedule of the stage today. We are going to see the content creator streamer Q&A at 4 p.m. Featuring streamers. I don't actually have the registrants, but I know Rafis is going to be there. Are you going to be there, Bistrol? Hi, BTMC. He's going to be in. Let's go. So tune in for that at 4 p.m. Next, we will have at 9 Nyanaro, Airy, GN, Yoxpai, Badu, and Ikoro showing off in a 1v3 negative AR HG side reading show match. I've actually never seen something like this before. We'll see how that goes. And we have one last show match today, or rather two show matches. Both Mania 7K and Mania 4K are going to be showcased in the show match organized by Yuan Crystal at 9 p.m. And I don't see any way we are not going to end stage stuff before midnight tonight. The schedule is so packed today. This is the most packed day. Anyway, thanks everyone for tuning in. I hope you had a great time and have a great time at COE. Thank you so much.